So I'm Michael Bachman. I'm a senior engineering director at Google. I've been at Google for about 14 and a half years. I guess my claim to fame is I was one of the first engineers within the discipline way back in the day. We had around 300 engineers back then, and we were still trying to figure out how to ship code into production without breaking everything. So we've come a long ways. The talk is going to really center around the discipline at Google and some of the key things that we did earlier on, and then where we're going to go. I believe engineering productivity has been a staple that's allowed us to continue to scale and stay relevant. There's not many 80,000, 100,000 employee companies that you know of that are nimble, fast, iterative, innovative, and can push and react very, very quickly in production. And you need this discipline to continue to scale and compete within the industry against smaller companies that can move a lot more quickly, and as others that are actually continuing to innovate and whatnot. So let me define. I'm going to spend a couple slides defining engineering productivity, and then we'll go from there. I do want this at the end. I'm going to go through some quick slides, but then I do want this to be sort of interactive, and I'll be able to answer as many questions as legally obligated or legally able to. Okay, so here's sort of the block diagram of sort of what our vision of engineering productivity is. Those in the back, you can't see it. But basically, it's our job to understand the entire developer workflow from authoring all the way through experimentation, production, and monitoring, and optimize that and remove frustration and toil from that process. And so we look at each individual aspect, we instrument it all, and then you have horizontals that specialize within those different categories to sort of streamline it. So how do we do this? We have about 2,000 engineers just in this discipline at Google. That's focused on making, this isn't just basic developer tools, this is developer productivity. They are responsible for making developers faster. We look at release compression, we look at developer compression, we look at build optimizations, and so on. We think of the scale that we operate at, we are over 2 billion lines of code that we have to deal with. And this number, I think I pulled from a couple years ago to be safe. We deal with over 60,000 code submissions every day. That's the throughput that we have to deal with. And we have our engineers are used to, sub-hour, sub-30-minute workflows before they check in that change. And if anything impedes them, we're not optimizing for productivity, no matter how often releases go out into production, which a lot of our core services are at least weekly, if not daily, automated, fully, no manual testing. That's on average. There's some, obviously, spectrums on both ends of it. And just to sort of resonate in terms of that this isn't QA or this isn't test, our average engineer to engineering productivity ratio is about 18:1. So we don't try to do QA. We don't try to do tests because we're not funded, and we're purposely not funded to do that. Because if you scale, and you can scale through empowering developers to writing production quality code earlier on. And if you can get to that point where you could do that cultural shift where the entire team and the entire company owns the quality of their code and the health of the product, you can move faster because you could actually check those things and assert the performance and the functional behavior and whatnot earlier on, so you could check it and forget about it and automate it and push it into production. And then you could react quickly later on if you have the right tools and whatnot set up. So as a discipline, we got started in about 2004, and we created sort of 3 job categories in the beginning. The first one, which we, again, if you think of the maturity of this discipline, we started with test. And we started checking in your CL, running tests, or running them at scale as fast and as easy as possible. Then we went to releases. And we do this across 3 job ladders. One is what we call SETIs, or software engineers, tools, and infrastructure. They are core to writing the instrumentation, the tools, and the infrastructure that we have that empowers the discipline. You have test engineers that are also technical engineers that do more of the systems thinking, breaking down complex problems, looking at gap analysis, looking at coverage analysis, and really driving and closing those gaps. And then you have release engineers in some areas that are needed in terms of separation and duties, pushing things into production, automating those workflows and whatnot. All right, so where we started off first, and again, there you have to get to the point where, okay, you can check in your CLs with confidence, then you can get your releases compressed and automated, and then you can go from there. What we really started in the beginning was continuous integration, continuous development, and release automation and compression. The entire goal was automated releases, automated check-ins, weekly releases, daily releases, and getting to the point where it was that bar. You then got to the point where you had automated what we call canary. The term comes from canary in a coal mine, where you're actually rolling out the percentage of production and traffic, and you have certain assertions and validations that happen to understand if that binary is actually going to be the one that you push. You have automatic failover, rollback, and whatnot. So this was the first phases of engineering productivity from probably 2004 to about 2008 and 2010. And then once we sort of solved this, you never really solve it, development's continuous, we sort of moved on to where we're going in the future. So I think beyond that, now we're sort of looking at, okay, how do you take this more forward? This is where we really expanded it. If you look at it, the pre-submit workflow, if a developer's ready to check in that change, and okay, let's say it takes them a week to get that change into production fully globally, that's the tail end of what they do. A lot of the pain that we've noticed at Google is authoring, code complexity, integrations, dealing with others. How do you design it? How do you refactor? How do you deal with code health? Once they get to the point where they have that CL or that change and they're ready to push into production, that's the last mile. So now how does this discipline impact everything else that they have to deal with? How do we make IDEs smarter? How do we make debugging easier? How do we make refactoring at scale better? How do we deal with experimentation so they can understand what they want to actually change and push out into production? And those are some of the next disciplines that we're trying to drive into. So I'm going to go into some major themes. And again, I'm going to blow through these so we can get into that interactive part, because I want this to sort of be a little bit more social for me too. Okay, the next piece is we have 2,000 engineers. How do we operate as a 2,000 person functional discipline? You need to standardize and sort of roll out some best practices across the company. And so we've started disciplines that are horizontals in terms of how do you deal with ML validation and skew detection with ML models that are getting pushed everywhere and dealing with that in production. What do you do with mobile? In terms of both mobile apps, but also the OS and the Android OS and the kernel changes and all of those aspects as a full stack. We need to be able to deal with that with the different devices and the hardware software interfaces that we're dealing with in Google. We have special infrastructure that we've implemented and rolled out, and teams across front ends and back ends and pipelines. And so it was further taking the individual problems that teams have to deal with and then streamlining it across different horizontal disciplines as well. So one of the first things that I want to sort of talk about is we're now looking at ML within the discipline that we deal with. So early on at Google, it was run every single test and every single change. And that helped provide, okay, you did it based on dependencies and other heuristics, and that got you a lot of quick coverage. But then that only can go so far once you have 40,000, 50,000 engineers. Imagine the amount of resources that you need to run every single test, every single change at that type of scale. So now, within your entire developer workflow, if you instrument everything, how can you build models to make better ROI-based decisions? Should I run that test? Should I push that change into production? What other code should I dynamically link in? All these different aspects in terms of understanding how to optimize both the resources and the time that developers spend and utilize. And so now what we're starting to really look at is the ML applications within the discipline. Next, what I like to say is Google's trying to continue to provide like this end-to-end seamless experience for our users, where your phone and your browser and your Chromebook and your watch are all seamlessly integrated. You could talk to your Google Home about it and get all of this. What happens is behind the scenes, all these products now are integrated with each other. And you can't get to the point where you could just push one monolithic, release into production for all of Google. So how do you do smarter unit integration, diff, load testing at scale without slowing down the entire sort of wheel? That's a big challenge that we're actually trying to deal with right now. With the tolerance that developers won't deal with anything other than like 30-minute, end-to-end cycle times and checking in their change when they have to depend on 10,000 different other services. Very difficult challenge. Next, in terms of watches and phones and the integration between hardware and software that we're starting to see, we're living in a world where software is moving just from a back-end service to an API to a front end. Now it's in your car, on your watch, on your phone, in your home, in your microwave, in wherever else you could think about. How do you deal with that hardware-software interface where you don't necessarily control the software? You necessarily don't control the hardware, you're merging it, you don't control the kernels or the drivers or all those different aspects. How do you handle the complexity of that at scale within a productivity discipline and whatnot? Those are also things that are starting to challenge us as a company. All right. Next, there's also what happens in production. So it's easy to go and streamline. I was talking to someone at Google and they were like, how do you solve productivity at this scale? And I said, well, if I wanted to make developers productive, I'd remove everything from the workflow and just let them check in anything that they want. Instant productivity increase, right? Like, hey, guess what? No more tests. Don't worry about anything. Just check it in. There we go. Productivity solved. What about happiness? Well, just have them go and to lunch all day and just check in whatever they want, and then they're good. But we have to close the loop with production. And what I mean is we have to understand what's happening with our binaries out there, the user flows. And it's not just about sort of functional QPS and is the binary up and serving and can it fail over and what we deal with that. But it's also, is the binary behaving or is the service behaving like we expect it to? And so you use production and you build assertions within the code itself or within the logging itself to understand how it's actually behaving versus it's just functionally up. And then so that's on the assertion side, as well as sort of closing the loop in terms of instrumentation and metrics and understanding teams might be productive, but maybe their system's falling over all the time in production. And so maybe we need to figure out what's going on with them. So to that end, we instrument everything. We want to know who's checking in what, who's breaking what, who's dependent upon what they're running, what they didn't run, what's happening in production, what's happening when we roll out a binary, what's happening with experimentation. So not only can you take a step back and see a holistic view of the productivity of a team and the gaps and the coverage gaps and whatnot, but also sort of where they're going, how they're trending, what's impeding them. And then you could actually use this data and feed it back into their workflow to be able to optimize it a little bit. And so this is us embarking on sort of a very metrics, insights driven workflow as well. All right. So that said, I wanted to blow through the content to set sort of the agenda and sort of the topic of engineering productivity at Google, but now I sort of want to open it up into a Q&A piece because we only had about 30 minutes. So cool. We have about 15 minutes for Q&A. Yes.
How's the 2,000-man team sort of organized, and how many your positions are there in there?
Yep. So I'll repeat the question. How is the 2,000 organization distributed, and then how many leadership positions, or how is it distributed across a handful of leaders?
Senior design.
Senior engineering leaders and whatnot. Okay. So basically, around 2008, up into 2008, we were a central functional discipline. Then the company went through a change and we broke up into what we would call business units or product area units. And so each product area has its own engineering productivity focused team. Most of them aligned with a leader, either a director or senior director or a VP. And then you have certain teams that have built horizontals that sort of try to tackle it across Google that are funded within some of those product areas given its focus or interests, such as Android might be tackling a lot of the mobile infrastructure to make mobile productivity or something like that. So did that answer the question? Okay, cool. Questions? Yes?
What are the key metrics that you use to measure developer productivity?
What are the key metrics to measure developer productivity? So we look at, so we use the term CL, which is a change list, which is a change that we're checking into the code base. We look at everything from how long that took to get submitted, how many times it was force submitted. It bypassed a queue that was supposed to run through, so we can understand the value of what tests we're actually trying to automate. We look at frequency of releases. We look at time it took to cut and push a binary into production. We look at what we call cherry picks or hot fixes into that, if some teams do that. We look at rollbacks. We look at code coverage. We look at issues within production in terms of outages or pagers or things like that. I can continue to go. We even look at code review time. We look at code, code review latency by person to see if there's certain people that are bogged down in terms of, focal points within the team. Maybe they get distributed better. We instrument basically everything from defects to check-ins to releases to what's happening in production. The challenging part is it gets to a point where an individual only like me can look at the entire view and try to tell the story. And so we're also trying to figure out how to make that easier to navigate what teams could do to improve the productivity.
You use this basic historical data to actually guide your sprint. So, for example, that based on this data, your team will be doing this, or you adjust the estimatives or somehow?
So the question is, I think it's more around sort of like agile development in terms of do you use this historical data to be able to guide sprints? We have different teams. If they do agile, we have different tools that measure their iteration velocity and what they could do outside of this.
But do you tie those?
No. Time together. That's a good point. I'm going to go to the back and then I'm going to go, yes.
Can you give the metric of rollbacks? How many rollbacks do you have? And second is, if you can take a real life example of a production outage and kind of tell us how sort of the various actors in your team, etc., play a role in fixing that or role in
Sure. So I'll answer the first question. The question is on average, how many rollbacks sort of we see? It depends on service and team and maturity and also their tolerance too. So there's teams that are trying to iterate and get a product into production, or they're trying to figure out what's going to stick to the wall. Sometimes you actually see releases and rollbacks high in those teams, and that's fine. If they can understand and they understand what they're measuring and they're purposely saying, hey, you know what, we want to experiment, we want to throw it out, we want to see if it sticks, we're fine rolling it back and iterating quickly through that, that's okay. We don't want to do that for like a $100 billion revenue business because you actually want to be a little bit more purposeful, and so those ones we actually try to get it down to,
When you say high rollbacks, what is the number? Or low rev, what's the magnitude?
So, it could range from, you might see one every handful of releases be rolled back to one out of once a month or whatnot. It really depends on sort of the maturity of the team and the stability of the team too. And so then your second question is in terms of dealing with an outage in production, what's our role? So there's sort of a couple different models at Google. There's a team called SRE that really is the lifeblood of keeping our critical services up at Google. They carry the pagers, they hand over the pagers, they deal with failovers and planning and whatnot. In those situations, I believe it's our responsibility to understand what happened and to understand how to close those gaps pre-submit and potentially post-submit leading up to the release as well. And so we like to participate in those. We might not necessarily resolve the fire as it goes, but there's times where we have enough knowledge of the system where we could go on call and help deal with what's going on too. There's other services that don't have SRE help that we actively play a part in that too. I'm going to go to you, and then I'm going to go to you with the benefit. Yeah, please.
So imagine you have at least several dozen disparate systems from build, testing, and deployment for different platforms, different applications, different languages, different code bases.
You're talking my world already.
How do you kind of collate all this data together to a point where you can actually learn from it and build models? Your machine learning models are. What is your process for bringing it all together in a way that you can look at it like holistically, or like use data from the disparate sources to make informed decision on productivity in a specific area?
Yeah, good question. So just to repeat it for video and everything else, if you have a world that's non-uniform in terms of languages, in terms of binaries, in terms of what you build and how you compile and how you test and how you distribute and how you push in production, how do you one instrument and then bring all that data together to be able to use within models or build insights from?
Yeah.
Get it? Okay. So it starts with building sort of a metrics and insights platform where it has a consistent data model, right? And a data store that you could push data into, and then you could build from and learn from that. And so then you actually have to go and build a handful of pipelines that deal with each of those type of situations independently. And so if you, let's say we have some new JavaScript service that we're trying to build up and compile and launch and this and that, and we need some insights from it, we might not necessarily have the entire pipelines to measure everything. We'll have to build the pipelines to go, but to feed into our common data store in our model, so then those can train over at least expected data, or at least be able to compare and feed it into the platform.
Do you have so if you have a standard model, is it something internal? Is it something you can share?
Internal right now. But again, sort of the reason why Google also wants to sort of participate more and actively in these type of forums is I feel like, and when we started engineering productivity back in 2003, 2004, we were maybe one of the first companies trying to do something similar because we recognized we had to do it to be able to keep up at the scale that we were growing at. But now I think if you look at the room and the amount of companies that are within here, I think the discipline's arrived and it's continuing to sort of propel the Valley forward, the high tech forward, and keep companies iterative fast. And this is great for them and the consumers and everything. I want to push us to open source a lot more of the innovations that we have, and then work as a collective ecosystem to solve some of these things too. So,
I kind of had a slightly related questions. Basically, do you have anything how do you visualize this data, or how do you help the teams not to get overloaded by the data and figuring out what's the first thing that they need to address?
Yep, that's a great question. So the question is, how do you visualize the data and get teams to actually address what matters and understand it? I think right now it's more of an art than something that's been solved. So there's a handful of certain metrics that we look at, which I sort of rattled off, that we try to at least have every team looks at in terms of how fast you get released into production, what's your release frequency, what's your rollbacks, what's happening in production in terms of pages and things like that. But then we've also started to get teams to look at what you call a project health level bar and say, okay, what would define project health level 1? And let's say certain criteria, certain velocity, certain sort of stability, define level 2, 3, 4, and 5 to get teams some kind of additional target that they could go to. And so we've rolled that model out into the company to be able to simplify sort of that world, as well as give them a target to hit once they reach, okay, hey, I can get basic code into production. Well, what's next?
Question. So I have a question. Let's say you have a tool, and how do you convince other teams to adopt this tool? Because you can go okay, here's the tool, use it if you want, or here's the mandate, you have to use this tool, otherwise again, don't get into production. How do you find the balance?
Yeah, that's a good question. So the question is, how do you find a balance if you're working in this discipline to get a team to use the tools, or do you mandate them to do so? I think mandates have to be very carefully used, especially at a company like Google, where it's pretty much bottoms up. So I think just like the old traditional QA and test disciplines never like the throw it over the wall model, I think our devs don't like the throw it over the wall model as well, right? And I've been in those situations where it's like, hey, you know what? I really think you should use this. Here, you should use it. And they say, what is this? How is this supposed to help my life? It's not designed appropriately, or it doesn't think about this or that or whatnot. I think you need to talk about their productivity challenges, look at the data, talk about what's slowing them down, and then try to build something, or at least agree to build something together. And then sometimes you'll launch it and they'll come, sometimes they won't come, and you'll rinse and repeat and try something else. But I think it's just a natural sort of engineering workflow of understanding what's frustrating them and their toil and what they need and what the priorities is, and then going and just trying to build something that they're involved in the design as well, just like we would like to be involved in the design too. That's a good question. I think in the back, and then we'll go over here. Yeah.
What is the input to the ML, and what if the ML learns not to run certain tests?
Yep. Good question, and we do that. So, so the inputs, it could be. So we do a handful of different things. I'll just, for your question, in case in point, we have models that look at the ROI of a test. So if a test is never failing over a certain period of time, it's a small test, it's a stable period of code, should you continue to run it pre-submit? It's a question, right? So you could build models in terms of, depending upon the change, here's everything that you've executed in the past. here's the past failure rates of what happened, and then you could and maybe even how long it took, and you could have some function that says, okay, I want to actually maximize the time I spend testing something and the odds or the odds of it actually catching a bug. And then you could play with that or give teams the ability to play with that. So they could say, hey, you know what, I want to skip tests up into this point because they've always been passing, and that what you do is you just push the risk post-submit. And then if you have a good sort of rotation that watches builds post-submit, you could react quickly, and then you could adjust your model or tolerances there too.
Oh, so post-submit, all the tests are running?
Yes.
Oh, I see, okay.
Yes. The flaky tests are a different story on how you actually handle those, but post-submit, everything's run. Because it doesn't necessarily, it just impedes the people that are dealing with the build, keeping those builds green, not necessarily developers trying to check in and change. Yeah, red shirt, and then we'll go over here.
Maybe along the same lines, do you do any sort of static analysis based targeted testing, anything on that territory?
Yeah. So we look at writing. So repeating the question, sorry, thank you, is do we do any static analysis based sort of assertions or testing or whatnot? The answer is yes. You have basic like lint checks and things like that around sort of design patterns or whatnot that are easy. And then you also could do sort of functional assertions that are run statically over the code to look at, hey, these type of things should never be done within the code. Please make sure we don't do this. Yeah. Question. You were going to ask a question, right? Yes.
So is there anything that your team has either started doing or stopped doing that once you did that, your reaction was like, man, we should have done this years ago? Like, what did you...
Yes. So like, stop doing. So I'll start with the stop doing because I think that's a harder question. There's times where it's easy. So engineers are sort of a limited resource, right? And I think some of the harder questions is if you have 2,000 engineers in the discipline and you have 50,000 in tech or whatnot, what problems should you tackle? What are the biggest problems you should tackle? How do you make the decisions to stop one thing and move on to something else? I think that there's a handful of stories where you go and you continue to sort of work in a particular domain because it was important a couple of years ago and you're trying to keep it on and it's very hard to switch into something new. I think we see that all the time, whether it's a tool and it's just not being used anymore, or it's just being harder to keep up with it and we just haven't made the call on either to rewrite it or to deprecate it or whatnot. I see those. And then something that we wish we did a while ago, I still think mobile development's extremely hard. I still think OS development is extremely hard. I still think we haven't solved and we're not getting ahead of the software-hardware interfaces and how to do that at scale outside of sort of emulation. I wish we sort of solved that. I'm living some of those pains right now on the Android side. I just feel like sometimes this discipline, given sort of we're new and we're maturing, we're also tackling the pain points once they're also sort of realized versus predicting them. Good question.
Do you have any kind of unified tooling, or do you see a need to write a lot of custom tools to address pain points of different teams?
Yeah, good question. I think one of the challenges within Google is I've talked about we're trying to standardize and we're trying to build horizontals that are standardizing sort of those workflows and tool sets and whatnot. We're striving to do that. The challenge within Google is there's this I want to build, I want to innovate, I want to build my own tool, and so there's always this constant build versus buy question where it's, well, their thing doesn't meet 10% of my needs, meets 90%, but I'm just going to go build my own one. Right, and there's also a question on, do you depend on someone else, or do you iterate quickly within your own teams, and just traditional engineering sort of challenges that product faces that we face and whatnot. I think we're still trying to strive to get to the point where the developer experience feels like a uniform, thought out experience, but we don't necessarily even have any PMs within our discipline either. So it's engineers trying to build that PM-like experience. Yeah, we're trying to get better.
So would you mind logging in?
Oh, yes.
And then while you're doing that, I have a question as well.
Okay. There we go.
So Google is famous for experimentation, including, the famous people analytics groups running A/B tests on where to place M&Ms and whatnot. How much of that do you incorporate in your tools, or are you thinking of, or maybe expanding that is, there's a lot of best practices and rigor that's gone into how production software is developed and deployed. How much of that translates, in your opinion, into what you're working on?
So I'll repeat the question. So the question is, in terms of engineering productivity, how much traditional sort of production rigor in terms of experimentation and whatnot, and sort of those insights and those type of workflows do we bring to our discipline? So if you're looking at impacting sort of the workflow of, let's say, 40,000, 50,000 engineers, you have to be really thoughtful about what you push to them. And so we will do a lot of experimentation. We'll do a lot of holdbacks. We'll roll it out to 1% of this group, and let's see, in terms of the measurements and the metrics that we're talking about, let's see what changes. To the question around, let's start skipping tests and see what happens. That was a big thing we had to look at in terms of, okay, are our models right? Are we going to start skipping things and move a bunch of pain to our post-submit build cops, and then everyone's not going to be happy? And so you go through the traditional sort of experimentation, launch, look at metrics, whatnot, rollout process, and we've tried to bring some of that rigor to the discipline as well. Especially if if we go wrong, you could stop Google for a day, and that's probably not the best thing. They'll catch up with me at some point on some Friday. I'll have an HR meeting, but hopefully not about that. Any other questions? Yes, but probably the last one, and then we're going to get to the next speaker.
So you kind of put up a slide there at the beginning, like 3 roles within the discipline, the test engineer, software engineer, test and release engineer. How has that changed as the discipline has evolved?
That's actually a great question. And so the question is, these 3 roles, how have these changed since the discipline's evolved? So I think release engineer has been, as a role as it's been defined, has been fairly similar, though the challenges in terms of integrations and building and releasing the code has grown in complexity. I think test engineer, it was modeled out of the original need of someone looking at a feature way back in the day when Google was trying to actually do testing or like QA or whatnot. That's evolved into more of a systems level, technical engineer that's breaking down, adding automation, doing insights, doing gap analysis, and really sort of trying to compress different aspects of it. And then one of the largest ones that's continuing to sort of change is our SETI, or software engineer tools and infrastructure role. This used to be what we called software engineer in test. And we renamed it once we sort of took a step back and realized that the discipline was really beyond test, and we moved past just that aspect to everything else within the workflow. And so we renamed it, and we're still it's becoming more of this generalized tool and infrastructure role as the discipline continue to expand in its scope. So, good question. All right. Thank you, everyone. And we'll do the next speaker.